Okay, so what we're going to do now is we're going to start section 6.2. We're going to do the introduction part to this. So section 6.2, it still deals with simplifying rational expressions. This time we're going to simplify our rational expressions when I have to add and subtract. We're going to add and we're going to subtract rational expressions. So again, I'm going to take you way, way back in time machine, back to 5th grade or something like that. I really don't even know what grade they do this in. And so if I have to add two things, so if I have 3 over 11 plus 5 over 11. Now, adding and subtracting, we tend to like a little less than multiplying and dividing because it's a little bit more of a process. What do I have to have? That's better. I got it out. What do I have to have in order to add two fractions? Have to have the same denominator. It just means that has to be cut into the same number of parts. So these have the same denominator. Now, when you do have the same denominator, that's a good thing. And so that's what we're going to talk about today. Okay, the first half of this section and where we will stop is we are going to talk about adding and subtracting today, same denominator. When we come back on Monday next week, then we'll talk about, okay, what if the denominator is not the same? So when you go into My Math Lab and you're doing your My Math Lab homework, they label the problems. They'll tell you this is a problem with like denominator, this is a problem with unlike denominators. So over the weekend, in the 5 days till we'll see each other, you can start the section 6.2 and do anything with like denominators. Okay, so it should be the first 5 or 6 or 7 problems. Does anyone remember the process now when I have like denominators? How do you add fractions? 3 plus 5, you add the tops or subtract if it's subtracting. 3 plus 5 is 8. And once I have the common denominator, what do I do with the denominator? You leave it the same. Exactly. You do not do anything. So all the work, when we come back, the work will be to make the denominators the same in some of them. But once you've done that, you have no other work to do with the denominator. This is 8 over 11. And then if possible, you reduce the fraction. So here's my problem. And then I've got several for you. And then that will be where we need to be in this section. So let's say I have this 7 over 2x squared minus 11 over 2x squared. Just as an aside, I like working with fractions that have x's in them better than number fractions. I think it's actually a little easier than the arithmetic. That's my personal opinion. So maybe you'll agree, maybe you'll disagree. Okay, so question 1. Do I have the same denominator, common denominator? Yes, I do. Okay, which that's my promise today. That's all we're going to be dealing with is common denominators. So 7 minus 11, you pop that into your calculator. What's 7 minus 11? Negative 4, indeed. And then the denominator, I stay the same. So 2x squared, you don't do anything to the denominator. Once you got the common denominator, it is settled. And then the last thing is, if possible, you reduce the fraction you've got. Do I have a factor in common to the top and the bottom of this? There's a 2. 4 is 2 times 2. I've got a 2 sitting right there. So 2 goes into 2 1 time, 2 goes into 4 2 times. So I'm almost done. Here's my end. My top is negative 2. My bottom is 1x squared or just x squared. And there we go. I've added, or in that case, subtracted my 2 fractions. So we're taking this in steps because I know adding and subtracting is difficult. I get it. Okay, so step number 1 is being able to deal with adding or subtracting when you have the common denominator. Okay, so we've got about 15 minutes before I'll pass back your tests. So we've got plenty of time. I've got like 5 problems for you to do of this. So here's your first one. You've got 6 over 5x squared plus 14 over 5x squared. So go ahead and add those and simplify what you get, please. Okay, question one, do these two things have a common denominator? Yes, let's hope so, because I haven't told you what to do if they don't. So just want you to observe that. We've got a common denominator. So now, once you have the common denominator, you just go ahead and add them up. So 6 plus 14 is 20. You leave the denominator the same, 5x squared. I can reduce this just a little bit. What's in common to the top and the bottom here? Indeed, 5 goes into 5 once, 5 goes into 24 times. So in the numerator, I'm left with 4. In the bottom, I have 1x squared, which I will just write as x squared. Here's your next problem. The first fraction is 3x over x plus 4, plus the second fraction is 12 over x plus 4. I'm just going to alert you to something in the next couple problems. 3x and 12 are not like terms. Okay, so don't smush them together and make 15. Okay. So your top is just going to be what it says. So it's going to look like some of the stuff we were simplifying in the last section. So give this a try. If you don't quite know what I just meant by those instructions, be patient, we'll learn, and then you're going to get another problem right after this one. Okay, so in the numerator, if you didn't struggle too much on this, in the numerator, what do I have when I have 3x plus 12? What does that look like? It's just going to be what? Perfect. Yeah, I'm sorry, not a trick question. I'm just trying to get you to think through this. These are not like terms. 3x has an x, the 12 does not have an x. So it just stays, the numerator just becomes 3x plus 12. That's it. Nothing else to do there. In the denominator, my denominator is x plus 4. Okay, so if you didn't know what to do with the numerator, that's okay. Okay, we're learning here. So I just took my two numerators, I've added them like we did over here. The only difference is over here, these were like terms. I could add the 6 and the 14 and get 20. Here I can't. And now I'm going to reduce. Now it just becomes a problem like we were doing in the previous section. So I'm going to factor a 3 out of the top. 3x and 12 share a 3. I'm going to factor it out. 3x divided by 3 leaves x. 12 divided by 3 leaves 4. I see that I have something in common to the top and the bottom. They both have an x plus 4, so I will cancel it out. Remember, x plus 4 divided by x plus 4, that's 1. So what that leaves me is 3 over 1. But probably something you learned at some point in arithmetic is that when the 1 is in the denominator, you don't have to write it. Okay, so we will just leave this as 3. When the 1 is the numerator, that indicates a fractional part. So you would have to write 1 over whatever, like we did earlier. Okay, so there's a difference depending on where the 1 is. Okay, I've got 2 more problems for us. So if you have any final thoughts or questions or concerns or conundrums or commotions or anything, please let me know. This one is x over x squared minus 9 minus 3 over x squared minus 9. Now that we've seen what to do with our unlike With our unlike terms, now you can take care of this in the same fashion. All right, the numerator, again, the x and the 3, these are not like terms. So the numerator just becomes x minus 3. I'm just going to write it as one numerator. The denominator, that's a common denominator, so I have x squared minus 9. We're going to finish this up by factoring. The top is already factored. There's nothing else I can do with the top. The denominator is a difference of squares. X squared is x and x. 9 is 3 and 3, plus 1 minus the other. And then x minus 3's cancel. Now this time, notice what's left in the numerator of this. A 1, I have to have that because that tells me that the rest is in the denominator. And that's an important thing to know. And then I have x plus 3 in the denominator. All right, last problem for the day. Okay, it's one more addition problem with our like terms and our common denominators. So add this and simplify. I've got 5x plus 6 over x squared plus x minus 20 plus 4 minus 3x over x squared plus x minus 20. So here we go. Check your work with mine. Any final questions you have, let me know. My denominators are exactly the same. That's good. That's the situation that we know how to work with right now. So it involves first adding my numerators. So I've got 5x plus a negative 3x. Those are like terms. So 5x plus negative 3x, that is 2x. Then I have 6 plus 4. 6 plus 4 is 10 over x squared plus x minus 20. No changes made to the denominator. If you did that, you did the addition 100% correct, you're doing great. All that remains now is one final time today. We were practicing a little factoring. So in the numerator, what can I do to factor the numerator? Take out a 2. They have a common factor of 2. So I'm going to take out the 2. 2x divided by 2 leaves x. 10 divided by 2 leaves 5. The denominator, x squared is x and x. The 20, the sign on the 20 tells me the signs have to be different. And then the two factors of 20 that are going to be 1 apart are going to be 5 and 4. So I end up, my last problem of the day, I do get to cancel. The x plus 5s will indeed cancel. I'm left with 2 in the top, x minus 4 in the bottom. And I'm going to caution you one final time. Do not cancel the 2 and the 4. Again, because the 4 is a term, it is linked together. Unless you do something with both of those, you can't just do something with one or the other. Okay, it has to be both when you're dealing with your terms. That's as far into section 6.2 as we're going to go today.